Hey folks, couple more terms from 1.2. Confounding variable. Confounding variable. So we were talking about, go back in time, we had explanatory variables and response variables. So imagine that there's a couple explanatory variables. So something in the news right now is the COVID virus and what is affecting the mortality rate. So some explanatory variables that people have noticed, significant ones, were whether or not people smoked. So there seemed to be a high correlation in mortality rate and smokers, and another was pre-existing conditions. So what is causing high mortality rates? Is it the smoking or is it the pre-existing conditions? But isn't there sort of a relationship between pre-existing conditions and smoking? So which one's actually causing it? So those two variables are confounding each other. Those two ideas are so intertwined and mixed up, we're not sure which one is actually controlling for the high mortality rates. Those variables are confounding each other. Kind of a complicated idea, but hopefully that made a little bit more sense. Lurking variable. Lurking variables are fun because it's something people usually forget to think about. So there's some famous examples. One is in Florida. There's a very high correlation relationship between shark attacks and ice cream sales. So whenever ice cream sales go up, shark attacks increase. And whenever shark attacks go down, ice cream sales go down. So there's a very strong relationship. And so someone might say, oh, well, hopefully right now you realize what the lurking variable is, what's really explaining what's going on. So someone might say, is it that the sharks like the glucose sugary blood of people? Or is it that when there's a lot of shark attacks, people get sad and go to ice cream for their grief food? No, it's none of that. So what's really happening, why is there a relationship between ice cream sales and shark attacks in Florida? Warm weather. So the lurking variable is warm weather. Another popular example is, I'll draw a pretty picture. That's not a good picture. What are those, power lines? So you know those power lines? So let's say you live underneath the power lines. It's a house. So they say that living under power lines is not dangerous. Okay. Well, then why is it that cancer rates for people living underneath power lines is greater than the general population? Is it that living under the power lines exposes you to more electromagnetic radiation? The physicists say no. Well, then why are the cancer rates higher? What is the lurking variable? Ponder for a second. Feel free to pause and ponder. And spoiler alert, the answer is, what are real estate values like underneath power lines? They're lower. So people living underneath power lines are of a lower socioeconomic class. Lower socioeconomic class is correlated with higher rates of drinking and smoking, which is correlated with higher rates of cancer. So with many things in life, it's a socioeconomic thing. So in terms of electromagnetic radiation, you're not getting much more electromagnetic radiation than from your toaster. So it's more about real estate values. Okay, lurking variable, and then census. So census, remember we were talking before, let me draw my picture. There's a population of interest. Can't talk to everyone, so you take a sample. Hopefully your sample is representative of the whole population. It does not have bias. So imagine if we actually were able to talk to every single person in the population. That is a census. Census is, oh, I can actually talk to every single person in the population. Okay. But sometimes censuses just aren't possible. In some situations, they are, but most of the time it's really difficult. So if the population gets too big, it's really difficult. So right now, you may notice we are doing a U.S. census. So every 10 years, it's written into the Constitution, we have to do the U.S. Census, and that's for two main reasons. We need to allocate seats in the House of Representatives based on population, and we have to allocate federal funds. So those are two major reasons. We also like getting the demographic information to help with statistical and economic modeling. So the U.S. Census, are we able to talk to every single person? No, it's super complicated. So technically speaking, the U.S. Census is actually just an insanely expensive, super huge sample. It's technically not a census. We call it a census because that's our goal, but we're not actually talking to every single person. It's just a super big, gigantic, expensive sample. So the U.S. Census is not technically a census. Okay, so just know that statistically speaking, census means you talk to every single person in the population. The U.S. Census is something different. We're trying to talk to every person in the U.S., see how many people there are, what their background is, etc. Technically a gigantic, expensive sample. I feel like that video was very rambling. Okay, moving on. We'll pause here.